We just did a demonstration with a slinky where we demonstrated the behavior of a wave going through that slinky when it encountered a boundary. What do we mean by that? Well, a boundary is that line between two different materials or two different mediums. So the first trial of the demonstration we did, we set a slinky wave down when we had a person holding on to the end of the slinky. In other words, the slinky wave was going down, hitting the boundary between slinky and person. When that happened, two things happened to the wave. Part of the wave was transmitted, not very much of it, but a little bit was transmitted. A lot of the wave was reflected. The part of the wave that was reflected upside down. Why? Well, most of it was reflected because the materials were very different. When we send a slinky wave down, we send a wave down, it encounters a boundary between two materials that are very different. A little bit will be transmitted, but most of it will be reflected. If the materials were very similar, then most of it would be transmitted and only a little bit reflected. But why is it reflected upside down as opposed to right side up? It gets reflected upside down when it's going from one medium to the other and the two mediums are attached. It gets inverted when we're attached. We popped out to the atrium and looked at what would happen when the slinky wave was going down vertically down the slinky, counted the boundary between slinky and air. It wasn't attached to anything. If it's not attached to anything, we found that the wave, a little bit was transmitted, but most of it was reflected again because the materials were very different. The part that was reflected right side up. So when the slinky or whatever it is that's carrying the wave is not attached to the other material, the part of the wave that's reflected will be reflected upside or right side up. Now, we couldn't really demonstrate this part. It doesn't work very well with slinkies. What if the wave encountered the boundary at an angle? What if it hit it at an angle? If this is the boundary, and the wave encounters the boundary at an angle like this, we'll measure the angle right here, we'll call it theta 1. Then the angle at which it reflects will be the same angle at which it struck the boundary at. So in other words, theta 1 will be equal to theta 2. We call that the law of reflection. You guys know that from playing pool, right? Playing billiards.
Good afternoon.
The angle of incidence will equal the angle of reflection. We'll talk about transmission a little bit more tomorrow.